Well, let's talk about self-healing. So let's say, for example, I've scanned my application and I've built a module, right, for this, enter vehicle screen, right? So I'm selecting a make, number of seats, and then I'm clicking on the next button. And when we used XScan to identify this control, right, we identified it by a unique ID called next enter insurance data. But let's say, for example, that my developer, right, is implementing a change and we're no longer using version 102 of the application, right? They've made a change and we're now using version 101, and they've changed that button or control, right? They've changed the ID. I think I've even changed the class name and obviously the name of the button on the screen here. So it changed from next to proceed. The ID's changed. The traditional process would be I would go into Tosca, I would rescan the module, and then identify the newly modified control. But as a way to even further lower the process of maintaining tests and modules is we have capabilities of what we call self-healing. So I don't necessarily always want to have to go and account for these minute changes. I want Tosca to do the work and figure out that even though I've changed the technical identifier, see if you can, as a recovery process, try to find this button and click it, even though the ID and the text has all changed, right? So we're not going to change the module, but in the test case that we're running, we are going to use test configurations, and we have functionality referred to as self-healing. And it's all based off of like a weighted combinatorial algorithm that says, if I can find similar or like-minded properties and have a confidence of 75% that I can identify that control, I'm going to try to click it to continue the execution. So I'll share the documentation that has, links to this and how you would configure it. But what I could do is, in essence, come in here and just simply run this, right? So it's looking for the next button based on that ID, but the developer made a change without telling me, the tester, and I haven't updated my test case, but I want Tosca to see if it can recover using the self-healing capabilities, right? So it's going to pause for a second because it's trying to find that control based on that unique ID, but it's been changed, right? So Tosca at runtime is basically going to interrogate the application and look for different IDs and controls and see if, based on, in this case, it's a weighted competence, that it can find that button and continue the execution, even though the application under test has been modified. So we'll give it a second. It'll find it, it'll click it, that step will pass, and then it would continue on to the next step. But the cool part is that we go a step further to say that not only when we ran it did it use self-healing, indicated by this little heartbeat icon, right? But it said that it couldn't find that control. And so the highest level of confidence was using the object based on the property of label proceed, right? So it was able to identify that control even though it was modified and I didn't account for that update in my module. The other cool part is if I right click, I don't even have to rescan that module. I could just say, Tosca, apply the self-healing properties to that module attribute. And now if I go into Tosca, I can see that it's updated that property for me. It's no longer using that ID. It's using this unique identifier of the label, and it's capturing those self-healing properties, right, to use in subsequent executions. So very quick example, but just to showcase that we do have self-healing capabilities based on, different weighted algorithms. I think there's other ways to do it, and you can control kind of those thresholds. But not only can Tosca recover on its own, even if objects and controls have changed, but then with a simple click, even update that module attribute and properties without having to do a rescan. So pretty powerful.